Okay, hello students. So I'm making this video on lesson number 3.5, and this is about problem solving using fundamental theorem of algebra and complete factorization and zeros and their multiplicity. Complex zeros come in conjugate and linear and quadratic factors. So all this I'll walk through those with the help of problems. Just wanted to know, let you guys know. Remember, fundamental theorem of algebra is any polynomial with degree n with complex coefficients. So remember, I can just write 3x squared. Just a simple case of 5x plus 2. And this is a degree 2. Now this can have at least, so it says at least 1 0. That's all. That's the meaning of. So I can have, see, the quadratic can have maximum. It can either cross twice the x-axis, or it can just touch the x-axis only once, which is like a multiplicity 2, or it may not cross, but still we can find. I can just create a quadratic like this 9, and I can see this one does not. It goes this way. Let's see, this is 9. So this one does not have a real root, but it has a complex root, right? So you can easily write this x square plus 3 square, which is directly you can write x plus 3i and x minus 3i. So and that's what I'm trying to say is they come in pairs. The complex zeros come in conjugate pair. That means one of the answers with this is, when is this going to be 0? So x plus 3i, either this is 0, or we say, okay, x minus 3i, this is 0. And when I solve for x, you get x equals minus 3i, and the other one is plus 3i. So the second one is a complex conjugate of the first one. So, so either it crosses twice, that is what we have seen here, or it touches once, or it never touches, so it has two complex solutions. So let me dive down directly to what is the meaning of. Let's solve the problem straight away. So in the class, I see some of the students were missing. So this is the first example I try to solve. There is a polynomial given, and the question is asking what are the zeros. So you have to find out the zero. Now, how do we find the zero? See, so the question is, when is this going to be 0? And you can see, first of all, the degree here. So the degree of the polynomial is, it is 5, and that x is like x minus 0 square, and then x minus 2 the whole cube. So the x square, which is c, can be written as x minus 0. It means when this will be 0 is either the x has to be 0, that means we put this equals to 0, or the opposite of minus 0 is 0, or this has to be 0, that is x has to be 2, 2 minus 2 is 0, or x, this plus 9 is minus. So these are the three zeros, each one, but then this one has a multiplicity 2, because it is repeating twice. The 2, which is the 0, 2 has a multiplicity 3, and the minus 9 is the raised to 1, so it has a multiplicity 1. So it's kind of a graph which crosses through 0, then at 0, at 2, and then at minus 9. See? So this is where it goes, and what it means is here, because it is the even, it has to be the the graph will be up this side, and the graph will be up this side also. Only thing here, it will take a turn like this. It will take a turn maybe, and comes like this. Okay, and there is a cube at x minus 2. Sorry, not at doesn't take. It goes. So these are the 3 points. So it starts from because at 2 there is a 3, and that's the odd. Because it's odd, it has to cross, but it little flattens. So it goes this way, and little flattens here, and maybe then it has to at 0, at 2. Sorry, at 0 the multiplicity is 2, so it takes a turn like this. It takes a turn, and maybe goes down. We don't know how far it goes down, but it has to cross. 9 has a negative 9 as a multiplicity. So this is how the graph will look like for the whole thing. Even though they did not ask us, I still thought of sketching. So it starts from out, and at 2 it has to cross, but it does not. It doesn't cross like that, but it flattens there, and it has to also take a U-turn at 0, and then it goes like this. I hope that makes sense. Let's go to the second part. So the second question is, given a polynomial, you're supposed to factorize and find all the zeros of P, real as well as complex, and then also write in the factor form. So what is that? So there are two parts here which I can't see. So first part is, can we factorize? So in order to figure out what are the zeros, and you can see there's x square here, but this x raised to 4 means x square, and you can see this polynomial x square, and you can see there's a x square which is multiplies here and it also here. So we can pull it out and use the distributive property and write this as x square plus 4. So this is your px. So now we want to put it each one equal to 0. So when is this going to be 0? Either the first one is 0, x square is 0, or x squared plus 4 is 0. So that means you put a square root and there's a 0, doesn't matter plus minus, so you get x equals 0. Or here you subtract for both sides and you end up getting x squared minus 4. And therefore put a square root, that means x is plus minus square root of negative 4. And you can write down, remember the trick is if b is positive and you have like that, this is same as square root of bi, which is I is the imaginary unit. So this will be two values, one with minus square root of 4. Square root of 4 is 2, 2 times 2 is 4. So you write 2i and x equal plus 2i. So these are the zeros and each one is the, so the first question, the real zero, this is the real zero. And these are the complex zeros. So when you write the answer in the Cengage, maybe you want to make sure if these are the two answers, you write minus 2i and then put a comma and then 2i in the box. That's it. But question is there another way to do, like all this work is like a low level maths, but we can still write directly also. As college bound student, we can directly say, okay, you have this, and now just write x is 0. That's the only way. And then if you have this basically means x squared plus 2 squared. And how do you factorize this? So you have a squared plus b squared. So the two factors are a plus bi and a minus bi. So in this case, the b is 2 and ax is this. So you can factorize this as uh, as. So as I said before, even writing that, I could just write this as x squared, and then you write two factors. One is x plus 2i and x minus 2i. So your factorization is complete. So this is the full complete factorization. Degree is 4, so you have 4 factors. X is repeated, and the zeros are, so x equals 0, then x equals opposite of plus 2i is minus 2i, and opposite of minus 2i is plus 2i, and you are done. I hope that helps. Okay, this is a polynomial of degree 4. So this time you have to reduce this to a quadratic. Now, right now you have the degree is 4. All we can write this as px is, so let me write on top so that I have enough room to write everything. So the px can be written as x squared, and then you can write square minus 5x squared minus 6. Now we'll plug in, instead of x squared, we'll put it to another variable p to make it like a quadratic. So it has to look like a quadratic. See? And now we need to factorize. The good thing is there's a 1, so you can easily write pp, because p times p is p squared. Now here there's a minus 6, so somehow we have to, I will write here, you have to find a pair of factors of 6. So what are the factors of 6? So the factors of 6, I make a table. One is 1 times 6 is 6 and 2 times 3 is 6. So which of these pairs, if you subtract, will give you. Now how do you know to subtract? Because there's a minus sign, right? So minus means subtraction. So, or if one of them has to be positive, one of them has to be negative. Now, the middle number is minus 5. This is minus 5. So when you subtract, it has to be minus 5. So we want to, first of all, when you subtract, it has to be 5. Let's say 6 minus 1 is 5. But it is minus 5. So if I want to put a minus 5, the bigger number takes minus and the small number takes plus. And you're done. Minus 6 and plus 1. So these are, now let's put it back, the whatever the p is. So you're replacing p back here. So when you replace this, you replace it by x squared minus 6 and x plus 1. Now, now, okay, I think I somewhere paused and I don't know what happened anyway. So now that you know these are the complex zeros. So these are the imaginary zeros, and you want to write in the factor form. So we have the four factors, and always we write x, 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 and then you will write the opposite of the zero. So if this is minus root 6, will become plus root x. The opposite of this will be minus, and opposite of this will be plus I and minus. So this is complete factorization. So, so what are the zeros? So we know the zeros, and which are the two real zeros? So the two real zeros will be this one and plus root 6. Of course, these are also complex. And they say, what are the two complex zeros? So we say, okay, minus I and plus I. These real zeros are also complex actually, but then they want to know which are the actual complex zeros. Okay, so I hope that takes care. So let me go to the next. Okay, this is fourth problem for practice. Now find all the zero of the polynomial. So given cubic with a degree 3 is a cubic polynomial. The first thing you're supposed to do is you're going to use the n-spire calculator to graph this and then figure out. Maybe somewhere it goes like that. So it will be shown one uh, factor, or they may give you something like this, and you find one of them, and the other two you have to use synthetic division. Once you have this, one of the zeros, you're going to use the synthetic division to find the quotient and then try to factorize it. So let's see what I'm talking about is, let me plug this in the desmos.com. Not Desmos, we'll use the n-spire. So you can put your calculator on and then okay, here it is. So write a graph and it is x to the power 3, right? Click minus 10x to the power 2 plus 29x and minus 30. Okay, that's, and then enter. You can clearly see we want to know that the graph crosses the x-axis only once. So we need to know what is the zero. Use the analyze graph and find the zero. So this is the zero, but we take one lower bound and then click and slowly take to the right side. You get 6. So 6 is already. So I'm going to use this 6 as one of the zeros to figure out the other two complex. Now the other two are complex. How do we know? Because you can see the graph here is it does not cross the x-axis. So straight away here, let's use so 6. Uh, so x equals 6 is the 0. So if x equals 6 is the 0 with multiplicity 1, so how do we find the rest? Okay, now uh, enter the coefficients of the variables. Here there's a 1, so put a 1, and there's minus 10, so minus 10, plus 29, and then minus 30. And then because 6 is already 0, put the 6 right here outside. Drop down the 1, 6 times 1 is 6. Combine, you get minus 4. That will be minus 24. And then if you subtract this two, you get 5. And 6 times 5 is 30. You get a 0. So that's a sign that really x equals to 6, it means graph really goes to the 6. Okay, so remember it was like this. So it goes to the 6. It means x minus 6 is one of the factor. So this one we need to factorize into factor x and x and x. So we need to know one of them is 6. So they want to know what is the other one. So we need to know this. Now, before even factorize this, one of the factor is this, then the other one is a quadratic. So you're going to use this number, the lower row, to find out what is the quadratic. So this was degree 3. So the next one will be with degree x, and we need to plug in those numbers. 1 minus 4, that goes right here, and then this is plus 5, so this is plus 5. So the quadratic is x squared minus 4x plus 5. The question is, there's a plus 5. Can we split this 5? Now this is to be written, so here, right now, the factor is, here the factor is a quadratic. So this is a factor, and we need to reduce this further. So question is, this 5, can I split 5 as, the only option will be 1 times 5, and it is plus. But because of this plus, 1 and 5 adds to 6. But the middle one is minus 4, so we cannot factorize it. So can we use a quadratic? So this is the time we're going to use a quadratic. So this is the equation. And what is, so quadratic formula is x equals minus b plus or minus, and let's plug in. So the a is 1, b is minus 4, and c is plus 5. So therefore x equals opposite of b. So this is minus b, but because b is already negative, so negative become positive. So it's just a plus 4 minus square of negative 4 will be, of course, we'll write all of that stuff. So this is a is 1, and c is the number by itself, that is 5, and divide by 2 times 1, because a is 1. Now this will be 16. You can do scratch work separately to see. So here, this part, the radicand will be 16 minus 20, which will be minus 4. So that will be, this whole thing will be, so that will be, this will be square root of negative 4, and directly we can write x equals 4 plus, and this thing, square root of minus 4i, is same as square root of 4 this, which is, because it's a negative, so you have to have an I, that will be 2i, and you get divided by 2, and then separate this, you get this 2 crosses out twice, this 2 crosses out 1, so you get 2 plus or minus, I forgot that 2 minus, so it's plus or minus I. So the two values are x equals 2 plus I and 2 minus I. So this thing now we can write as x minus 6. And now you have x and x, but this was just 2 plus I. This will go minus, minus, and then I'm going to enter the actual 0, which is this one, 2 plus I. So that's 2 plus I, and the other one is 2 minus I. So this will be, and then we can't keep it like that, so it should be x minus 6. And this, when you open this, this will come, use the distributive property, it will become x minus 2 and minus I, and the other one is minus 2 and plus I. So this is the complete factorization. So complete factorization theorem says that if your degree is n, whatever the degree, then you can write n factors. So these are 3 factors, because there's a degree 3, so it has 3 factors. This is called complete. And if you write this one, this one is called a linear, and the other one is called a quadratic. Quadratic. So even they did not ask you, they only ask you what are the zeros. So you were supposed to find only the zeros. So there was no question to do. That this was not needed, but I still thought of. So your answers are 6, and this one is 2 plus I, and the other one is 2. So in the Cengage, make sure you put these things. Okay, let's go on. Let me check. Do one more problem, practice problem, problem number 5. So, so practice problem number 5, find all the zeros of the polynomial. So this time they give you a degree 4 polynomial, and then we need to figure out, because there are 4, we need to figure out at least the graph crossing, maybe something like this, I don't know, and we have to figure out that. So on your calculator, let's put on the Desmos calculator and see what we get. So let me pull the. So I will start with the new page, new document, and graph the equation x to the power 4 minus 2x to the power 3 and minus 14x to the power 2 minus 2x and minus 15, and then enter. I can see it go. I think I typed it wrong. So if you want to edit this, click on this one and here, and then go right. That's where I will need to change and put a minus sign there, and then enter. And you can see the two number, the graph crosses twice, and we don't know the other one. So you want to know what it is. Of course, you know it is minus 3 and already 5, I think. But just to check, better to analyze. 0, go to the left, go to the right, and you get minus 3. And the other one also analyze, go to the left of this and go to the right, and you get 5. So your values are minus 3 and 5 are two zeros. So go back to this. So let me use the synthetic division. So first of all, the two factors are, at least we know the two factors, that is, the zeros are the zeros are negative 3 and 5. So in factor form, it will be x plus 3 and x minus 5. Of course, they did not ask us to write the factor form, but I still am writing. All we need to know is what are the other two zeros. So use this. So let's start with the first one, minus 3. Write that minus 3 right here. And all this. So if the 1 will go 1, and minus 2, minus 14, minus 2, and minus 15. Okay, let's check. It has to be a factor. The remainder has to be 0. Let's drop down the first. Minus 3 times 1 is minus 3. Together is minus 5. You multiply this, you get 15. And then it adds to 1 together. And 3 times negative 3 times 1 is negative 3. And this together is negative 5. And then negative 3 times negative 5 is. And good job. So there you go. You got this part. This is what you use to get a depressed quotient. So when you divide this thing, this polynomial, when you divide it by the factor x plus 3, what you get is this one. So I'm going to use this one. So let me write a separately another one. So this number goes right here, 1, negative 5, 1, negative 5. And because the second 0 is 5, so I'm going to use that 5 here. Let's multiply. So drop down 1, 5 times 1 is 5, 0, 5 times 0 is 0, add 1, 5 times 1 is, you get 5, and you get 3 numbers. So now you have a depressed coefficient. So in the beginning, the degree was 4. Now, so this is the one we got. Actually, this polynomial factor is of degree 4 because, sorry, 3. This was 4. Now this is 1. So 1x cubed minus 5x squared plus 1x and minus 5. So this is what you get. In between, we don't need this. I'm using only this so that you can get further. For me, this is important. So now, those factors are okay, but this is what we got right now, the of degree 2. So from degree 4, we got degree 3. And from degree 3, we can get another factor, and that is 1x squared, because the 3 gets reduced to 2, and then there is a 0 plus 0x plus 1. And what you get is basically is x squared plus 1. So this factor is x squared plus 1. And then question is, what are the zeros? So once you get this, so let me write it again. So x plus 3, remember, and that was x minus 5. Now you got x squared plus 1. If I want to know when is this going to be 0, so of course, we know we already got this is minus 3, this is plus 5, and now I have to make this a 0 of x. So x squared plus 1 is 0. And then subtract this, and you get x squared equals minus 1, and x become plus minus square root of minus 1. So you get x plus minus I. So the zeros are 1, 2, and the other two are x equals minus I and x equals plus I, and you're done. So your answer should be written with minus 3. So I'll write minus 3 minus I plus I with a comma and a plus 5, and you're done. So I hope this helps. And in the factor form, we want to write this in the factor form. Remember, we did write here, so that could be written as is x plus 3, x minus 5, and then the other one is x plus I and x minus I, and you're done. So let's do another problem, 6 practice problem. Find all the zeros. So we need to try to figure out what are the 4 zeros. And the first thing is we need to plug this in. Remember, in the next lesson number 3 point, there's a rational theorem says in the next one that if there is a 1 here and a 36, you can do 36. It's like P over Q, and you try to find all the fractions possible. So first of all, what are the factors of 36? Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 4, plus or minus 6, and plus or minus 9, and plus or minus 36. See? And here is the 1, so it doesn't matter here. Suppose if you divide, you get back the same thing. And you have to check each one of these to know which one goes. So you're going to end up trying to figure out 1, 2, like this synthetic division to know which one is a factor. Coming along. So let's go directly and plug it in the Desmos. So I'm going to go this one, new, no, and then graph. So x raised to 4. And then minus 6x to the power 3, right click, plus 13x to the power 2 minus 24x plus 36. And you can see it looks like this is degree 4, which is our part, and one of the zeros is given, but it takes a turn. So now, so let's check what is the zero. You click on this one, analyze 0 to the left and to the right, and you get 3. So the 3 is the 0, which is a multiple of 3. Let's check. Let's put directly the 3. X equals 3 is one of the 0. So x equals 3 is one of the 0. So we are done. So we want to know whether this is repeated. So right. So put this 3 right there, and then this numbers. So 1 minus 6, 13. negative 24, and 36, right? And let's work on it. So this one drops down. 3 times 1 is 3. Together is minus 3. This multiplies with minus 9. Together will be 4. 3 times 4 is 12. So negative 12. And 3 times negative 12 is beautifully you get 0. See? Now the original polynomial had a degree 4. And now that we have a quotient or depressed polynomial, this polynomial cries and becomes smaller. It means the 4 becomes x raised to 3. This is 1. Then this is minus 3. Then it is 2. This 4, which is positive, and we put x, the number by itself. So this is the. Now we want to know, because we saw on the graph that the graph is taking U-turn at 3. So we can use one more factor. Again, use the same 3 twice. So put a 3. And you'll put this number again 1, minus 3, 4, and minus 12. Right? So this time, so drop down this 1. 3 times 1 is 3. This is 0. 3 times 0 is 0. You get 4, and you get this. And 12, and you get 0. Oh, that means 3 is 0 with multiplicity 2. So you have another x equals 3. So now we can, from the degree 3, you have to create another one with degree 2 here. So we'll have to plug in those coefficients. So this one goes right here, this 0 goes here, this 4 goes 4. So the whole thing becomes x squared plus 4. So now we need to put this equal to 0, because the question is asking us what is the 0. One thing, you could directly also use my formula that I gave you. You can make it like two factors, and you can say this is x plus 2i and x minus 2i, because it's of the form a square plus b square, and then say, okay, the answer, the opposite of plus 2i is minus 2i, opposite of minus 2i is plus 2i. So you already got the answer. But if you get confused with this, you just solve for x. You subtract 4 from both the sides. So subtract 4 both sides, and then x squared is negative 4. And then x equals plus minus square root of negative 4. And that way you get x equals plus or minus square root of 4 is 2. And there's a, sorry, this I, this minus makes it I. So you have two answers, minus 2i and plus 2i. But the question, so your zeros are 3, 3, minus 2i, and plus 2i. But if sometimes they ask you write all of them, even the repeated one, or sometimes you are supposed to write, if anything repeats, write only one. So I'm going to write this negative is there, so I'll put negative 2i, then this 2i, and then plus 3, and you're done. So those are the zero. But if you want to write in the factor form, you'll have to write x minus 3, x minus 3, x plus 2i, x minus 2i, or you will skip this and write 2, because 3 has a 3 is a 0 with a multiplicity 2. So I hope this makes sense. Let's go to the next one. Okay, so this is the last one I'm doing, as it's going to be almost 10:30 night time. I just want to don't. I'm tired, but still I'll work to another one. Let's look at this polynomial. The question is factorize the polynomial into linear and irreducible quadratic factors. Now, what is the meaning of irreducible? I just give you an example, x squared. Let's see, you got x squared plus 9. And now the question is, can you factorize this into further factors? No, because this one it's already positive. You can't factorize this further unless you want to factorize into complex numbers. So these is, instead of coefficient, it is with real numbers. Okay, this is with real numbers instead of coefficient. That's a mistake there. This should be in numbers here. That means these are the number plus 9. But if you want to factorize it, you have to further factorize it. Then you'll have to do x squared. Sorry. So it will be x squared plus 3 square, and then you can easily factorize into factors with complex number. That means you have to put x and x, and because there's a 3, put 3 plus with minus and I, because a square plus b square is a plus bi and a minus bi, right? So this is how I like to do. But if you feel it's difficult, and you can say, okay, such example you can always put it. You want to know, uh, write in the complex, then you put this equal to 0. You say, okay, x squared equals minus 9, and x equals plus minus square root of 9, and that becomes plus minus 3i. See, I missed the 3 there. Okay, so the one that we gave is, you're supposed to, as I say, you're supposed to, let's see, if I want to plug this as x squared is p, because there's a 4, so it becomes something like this. Okay, we can first reduce this. Okay, that now, because this part, let's see if we can use our menu without graphing calculator. This will be p raised to p square plus 5p minus 36, and you can see there's a 1, so we can easily put p and p. And there's a 36, we can split into a lot of them, like the 1 times 36 is 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. So among this, because there's a minus, you check on which of the pairs it will give you 5. When you subtract, gives 5. And you can clearly see 9 times 4, 9 and 4, if you subtract, gives you 5. But because there's a plus 5, the bigger one takes plus 5, and the smaller one, so bigger one takes plus 9, and so this is what we get, and you can write it with the help of, put it back, and you get x squared plus 9 and x squared minus 5. So this is what you get, px. Okay, and the question is, can we factorize? The question is linear and irreducible quadratic factors. So this part we can write x squared plus 9. Remember, this one is 5 can be written as square root of 5. I'm gonna use the use the difference of square, and you see this become x squared plus 9. And the other one is, you can use a squared minus b is a plus b and a minus b. So this will be x plus square root of 5 and x minus square root of 5. So these are the linear factor with the real zeros. But then they want us to write this is not coefficient with complex numbers. So factor with complex. So how do I factorize this? Remember, we can write this as 3 square. The other two are already factorized. Oh, 1 plus or minus. And this side, this thing, remember, this is of the form a square plus b square. This is a square, this is b square. So just want to remind, a square plus b square is a plus bi. So this becomes, so this remains the same. Only the first one will change, x plus 3i, and the other one will be x minus 3i, and you're done. So these are called these are complete factorization. This is complete all factors with complex numbers. So you're using complex numbers to factorize. So the first part is, this is without complex. So this is the one reducible, or you can also write this part. So this is the right way. This is uh, factors with real zeros, and this is irreducible. So these are the real factors, and this is irreducible. So these are, let me write, make it nice and clean so don't get confused. So these are, your final answer is this. So the second part is, they want is to find out the, so